is a triple simultaneous equation question. There are 3 equations and 3 unknowns. We have to find the value of x, y and z that fit the 3 equations. 3 equations, 3 unknowns. I've put a line through my z so they're not confused with the number 2, and I've labelled the equations 1, 2 and 3. Equation 1 and equation 2 both contain x. So I hope that if I take one equation from the other, I will successfully eliminate my x. X take away x is no x. 2y minus y is plus 3y. 3z minus 6z is minus 3z. And 2 minus 9 is minus 7. I'll call this equation 4. 3y minus 3z equals minus 7. If I had another equation with just y and z in it, I'd be able to eliminate either y or z and get an answer for the other variable. If I take equation 1 and multiply it by 2, I get 2x plus 4y plus 6z is equal to 4. Now equation 3 is 2x minus y plus 3z equal to 13. So if I subtract 2 of equation 1, subtract equation 3 from 2 of equation 1, I will get 0x, 5y, 3z and minus 9. I'll call this equation 5. So equation 4 is 3y minus 3z equals minus 7, and equation 5 is 5y plus 3z equals minus 9. Both of these equations have 3z. One is a negative, the other is a positive. If you add these together, you'll get 0z, so z is eliminated. Minus 7 plus minus 9 is minus 16, and 3y plus 5y is 8y. That means that 8y is equal to minus 16, and y will then be equal to minus 2. If I divide this side by 8, I'll get y, and this side by 8, I get minus 2. Taking equation 4, and knowing that y is minus 2, I can then find a value for z. So this is equation 4 with y inserted in place with a minus 2. 3 times minus 2 is minus 6. Minus 3z equals minus 7. If you add 6 to both sides, you'll get minus 3z is equal to minus 1. If you divide each side by minus 3, you get z equals 1 over 3. So y and z are now both found. Finally, the last piece is x. To get x, just pick any of the first 3 equations. X plus 2y plus 3z equal to 2 is equation 1. X plus 2 y's, which is minus 2, add on 3 z's, which is a third, equals 2. 3 times a third is 1. 2 times minus 2 is minus 4. And x is simply x. And 2 is simply 2. X minus 4 plus 1 is x minus 3. If you add 3 to each side, then x becomes 5. So, the solution to the simultaneous equations are x is 5, y is minus 2, and z is a third. It would be useful to now look at the mark scheme to see where marks are allocated. The first mark allocated is a method mark, and that is given to the candidate when they attempt to either add or subtract 2 of the equations. The next mark given is a mark for working. It's given to the candidate when they add the two equations together correctly. The third mark is a method working mark. This is where they combine two of the equations with three unknowns and get the correct answer. The fourth mark is got by the method of adding two equations with two unknowns to try and eliminate simply down to just one unknown. In this case, it was the 16y equal to the minus 32. A working mark is got for finding out what y is correctly. And then a method working mark is allocated for finding z correctly, and a method working mark is allocated for finding x correctly.